Hi class. Today we're going to finish talking about chapter 3 in our Prelude to Programming book. If you remember, we had gone into our Canvas course and in our module section, we're in lesson 3 and we're looking at the lesson 3 PowerPoint. So I have that downloaded. I'll open it. So we left off, we had talked about pseudocode and hierarchy charts and input processing output charts. And today we want to talk about flowcharts. And flowcharts are another tool for programmers to use to document their program design. And with a flowchart, we describe the flow of a program module's execution with diagrams. So it's completely different than a hierarchy chart. If you remember, the hierarchy chart only said what modules or subprograms called other modules or subprograms. With the flowchart, we're talking about the logic of our algorithm. Lots of people like to use flowcharting to learn how to express algorithms. Some like using pseudocode better. And many programs are designed using a combination of the two. I want to look at some flowchart examples. Here's an example. And looking at this flowchart, first of all, take a look and you can kind of see what's going on here. We're trying to determine if we should plan on playing golf or not. So we start out, check the weather channel, have a decision here. Is rain predicted? If it is, we'll just stay home. But if it's not, we'll play golf. Now, some things about this flowchart. First of all, it's really easy to follow because it has a definite beginning and ending. These symbols, these really large ovals, are called terminating symbols. They terminate both ends of the flowchart, the beginning and the end. Next, we have processing symbols that are the rectangles. So in our rectangle, we try to do one thing or one step of our algorithm. Notice that we could have a comment or an annotation associated with one of our actions. Now, anytime we have a decision to make in a flowchart, we show that using a decision diamond. We use the diamond symbol because it works well, giving us a yes path and a no path, or a true path and a false path. Either way, we want to make sure that we have lines with good arrows to show us the direction our logic should flow. So really good flowchart. Now here's another flowchart that's not so good. We've got some symbols and we have some decision symbols that look like they're being used a little bit properly, but we have a termination symbol kind of in the middle and a little bit of confusion here. So this flowchart could convey a message to us, but it doesn't do it as nicely and as well as the previous flowchart. One thing about this flowchart that we can note, though, is it does show us looping. So in this activity, we've got to decide if we've got homework to do. And if we have less than 12 hours, if not, if we still have plenty of time, we can do some other things and periodically check in on our time. When we finally only have 12 hours, we'll start working. So again, this flowchart doesn't quite convey the message as well as our previous example, but it does get the message across and it does show us how lines with our arrows can convey logic and the flow of our program. Now I have a really messy flowchart here. Yuck. Look at this. We have lines going everywhere and arrows going everywhere. It's kind of like this wiring job here. Well, when we look at this, we see that using the rules and following the guidelines that we're given for developing a flowchart will help us make sure that our message can be understood by others. So our basic symbols, our terminator at the beginning and at the end, our process symbol that's a rectangle. We use a parallelogram to represent an input or an output operation. For example, when we want to prompt our user for data or write data out to the screen. We use the diamond for decision making, and we can use the small circle to indicate a connector from one part of our flowchart to another part of our flowchart. So here's an example. On this slide, we have our sale price program pseudocode that we had talked about last time, where we have our main module that declares variables, displays a nice startup message, then calls our other modules, our input module, prompts for our data to load our variables that we need for input. Then our calculation does any necessary calculations, and our output module displays our output variable data to the screen. So here's the associated flowchart. We start out with our terminator, then our welcome message here. We have these two write statements. So we didn't have to be super specific in our flowchart, but we need to convey the fact that that welcome message is going to be output. And then we're going to use the same parallelogram symbol to indicate that we're going to ask for input of these variable names. We'll have each of our calculations in their own process box because they're each important parts of our algorithm. And then we'll output our information as required in our output module. Notice that our flowchart just shows a straight through logic. It doesn't really convey our different modules very well because it just shows the exact logic and algorithm that we need to follow. So remember, no matter how we're working, we can have these different logical structures. Sequential, where we just have a sequence of statements that we just execute in order. Next chapter, we'll see selection, where we can have decision making that causes branches in our logic. And we'll see after that that we can have repetition, where we repeat statements or perform activities more than once in a looping type structure. Now, this flowchart gives us some further examples of some decision making. Great job. And we want to kind of summarize here at the end of our chapter, talking about some style pointers. We've seen that modular programs are desirable, more desirable than just sequential statements. We want to use descriptive variable names. It's nice if we provide a welcome message to the user. We always use a prompt to prompt for input. We always annotate our program output to supply information about the output, and we always add comments to document our programs. Great. Okay, so let's take a look then at Repl. And if you remember, last time when we were working in Repl, we created our music program. I'm going to go into this music program pseudocode, and I'm going to look at our files. Now, if you remember, we didn't have any Python code to add here in our main.py file, but we created an ipo.draw file that contains our input, processing, and output diagram for our number of songs program. And then we created a text file to hold the pseudocode for our number of songs program. So the textbook has shown you how to do that sale price program, pseudocode, and all of the different pieces. And today we want to look at how to do a flow chart for our music program. I'm going to share this before I go any further. Make sure everybody's got a copy of it. So let me see how to do that. I'm going to generate this join link. And I'm going to put it in our Teams. So on Teams, go to our meetings channel, and you should see a new conversation that will be this link. Okay, so our Teams and in our meetings link, you should be able to find that. Okay, so now I'd like to add a flowchart to this. You should be able to grab that link and get to this repl if you didn't create your own. Please make sure that you create one so that you get the experience. But I want to create a new file here. And of course, I want this to be my flowchart. It's going to be one of those draw files because I want to use those shapes. So flowchart.draw. Well, I'm going to start out, let's see. I guess I'll use my ellipse. And this will be my start. Now, in your textbook, there is some information about a flowcharting tool called Raptor. And if you want to download that and try some of the activities, you are certainly welcome to. We're not going to do that as part of our class, but you certainly can. In this flowchart, after we start, we'd like to do one of those welcome messages. Let's put this here. And I don't know, let's see if I'm going to be able to make this into a parallelogram. And not really. We might have to assume that our input output has to be a little different. Let me try a decision diamond. I don't like that either. So I'll use the rectangle. And then I'll do the free draw and kind of draw a parallelogram there here with it. Oh, not too good, but that's the best I'm going to be able to do. And we're going to say that we're going to display a welcome message. I pressed Shift Enter to go down to the next line without doing anything destructive. Okay, after we display our welcome message, let's go back to our pseudocode. I'll add that. Right. Welcome to the songs. Okay, then we wanted to do our input. How many songs would you like to purchase? All right. So I want to do another one of these awesome parallelograms. And I want to say input songs. Then we had that formula, right? We wanted to calculate our total. Songs times 0.99. And we found that if we put the 0 before the 0.99, it was easier to read. And then we want to output our message. I apologize for this ugly parallelogram. Now we need to connect all of our flowcharting symbols with our arrow. So I'm going to start here and connect, and start here and connect, and start here and connect. And then finally, I need to have a closing symbol. I will just say end. And I'll use my line to show that. So in repl, we don't have as many flowcharting symbols as our textbook would enjoy, but we are being able to do something. And you could try doing a line for the parallelograms, and maybe that would work better. I'll leave that up to you and see what you can do. Now they say double click or press enter to edit points. You may be able to do all sorts of awesome stuff with this. I hope that you can. Now our basic flowchart here, as you can tell, didn't require a lot of effort, but it does document in a sequential fashion what our program is going to do. We could almost think of this being a predecessor to our pseudocode, right? Where we say, well, I could have started with this flowchart and then created my hierarchy chart. Let's create one of those. Hierarchy dot draw. In our hierarchy chart, we only need rectangles. We have our main, and our main calls our input and our process. And our output. And we can do some nice lines to connect all of those, because they're all called by our main. And let's see, I think I'll get rid of that. And I'll do a line down here. And that way I can connect my arrow to this one, and an arrow to this one, and an arrow to this one. Perfect. So now in our example, our music program, we have all of the different kinds of documentation that have been presented to us in chapter 3. We have our input processing output diagram, some pseudocode, our hierarchy chart, and our flow chart. So those will serve as our examples. In your textbook, we're going to be looking at the chapter review and exercises. And at the very end on page 177, we're going to be looking at the programming challenges. So here's our first one. You're going to do number 2 with your group first. Now you're each going to turn in your own repl assignment. And you, of course, you'll share in the same way that you saw me share with you or review that. But for problem number 2, we're working with supermarket, and they'd like to be able to compute the unit price for their products that they sell. So to do this, the program should input the name and the price of an item per pound and its weight in pounds and ounces. So we're going to need 4 input variables there, aren't we? The name, the price, the weight in pounds, and the weight in ounces. We'll then use the formulas that are presented to us to come up with a unit price and a total price to be displayed as output to the user. Work with your group. Your requirements are to have a flowchart and pseudocode for this, and they should be in the same repl, and you would be able to turn in the repl sharing URL to me for the assignment. After you finish with number 2, you and your group should work on number 4. In number 4, we're working with Shannon and Jasmine, who are both bowlers. Each of them bowl 3 games in a tournament, and they'd like to know their individual averages for their 3 games and the team average. We want you to allow the user to input the score for each player, then output Shannon's average, Jasmine's average, and the team's average. You're going to need the following variables. It's kind of difficult, but try to stay within the confines of these variables as you work through this program. If you can't, well, that's okay, but try to stay within those confines. You'll only need this formula to calculate that team average, and then you'll display all the helpful information. So in teams, you are able to work with your group. So you are able to find your group in Canvas. And then once you've determined what group you're in, you can go work with your group on Teams. You guys can start up your own Teams meeting to have a meeting if you like to discuss how to do these problems. That's up to you. I hope you do, because it'll be much easier if you work with your team than working all alone on your own. All right, how to find your team. Go to People, Project Groups, and then in our project groups, you should be able to determine which group you're in. Remember, this is the same group that we looked at for our shared notes. I'll get rid of any people who have dropped. I think we had a drop. So work with your group to make your pseudocode and your flowchart. You can use Replit. If one of you creates a Replit and then invites the rest, you guys can all work together on the same Replit, and then you can all turn in that same URL. Just make sure that you have it so that you can get to it if you need to return to it, to refer to it. And you should want to have some other information open, like maybe the pseudocode for this program, but something to use as an example. Now I have to leave you on your own to finish that this week. So please work with your group and please be productive in getting both of those pseudocode and flowcharting assignments completed. Thanks. Have a great day.